On the morning of September 23, 2025, the Bay Area awoke to a familiar hum of traffic and coffee pots gurgling to life. But at 7:11 a.m., the ground interrupted with a low rumble that quickly turned into a violent jolt. In Berkeley, frames rattled and books tumbled as a magnitude 4.3 earthquake struck. Across the region, tens of thousands felt the jarring motion. The shaking ended as abruptly as it began, leaving behind a flood of questions. Was it a mere tremor or a warning of something bigger? The USGS confirmed the quake, a wake-up call in every sense. It was a tangible lesson in geology, reminding everyone of the seismic reality of living in California. Conversations shifted from traffic to preparedness, prompting discussions about emergency kits and securing furniture. The jolt was a reminder that the ground beneath us is a dynamic, shifting puzzle. Are we truly ready for the next big one? Seismologists have special names for quakes in a sequence: foreshocks, mainshocks, and aftershocks. The main shock is the most powerful, causing the most damage. Foreshocks are smaller quakes that precede the main shock, but identifying them in real time is tricky. Aftershocks follow the main shock as the Earth's crust adjusts. They can continue for weeks, potentially causing further damage. The 4.3 quake in Berkeley raised the question: was it a standalone event or a prelude to something larger? Understanding these terms helps us grasp what scientists look for after any earthquake. It's a reminder of the complex dance of tectonic forces beneath us. After an earthquake, the pressing question is a bigger one coming? While we can't predict earthquakes, we can use statistics to assess the risk. Most small quakes are not foreshocks to larger ones. After the Berkeley quake, USGS models suggested a 5% chance of a larger quake following. This means 95% of the time, the initial quake is the main event. A 5% chance might seem small, but it's significant enough to warrant attention. Officials urge preparedness based on this statistical possibility. It's a numbers game, a reminder to stay alert and ready. The science of forecasting is evolving, but for now, these probabilities guide our response. After the Berkeley quake, seismologists focused on aftershocks to understand the fault's behavior. Omori's law predicts aftershocks will decrease in frequency and strength over time. Deviations from this pattern could indicate building stress. The Bay Area's seismometers recorded every tremor, looking for anomalies. Initial quiet after the quake suggested it was a typical main shock. Tracking aftershocks allows USGS to update forecasts in real time. If activity remains low, the probability of a larger quake drops. This dynamic forecasting turns post-quake hours into critical observation windows. The Berkeley quake occurred near the Hayward Fault, a major branch of the San Andreas Fault system. This fault runs through densely populated areas, making it a tectonic time bomb. The Hayward Fault produces major quakes every 150 years on average. The last major quake was in 1868, making the fault overdue. A repeat could cause catastrophic damage and threaten thousands of lives. The fault runs under critical infrastructure, including UC Berkeley's stadium. Each small quake is a reminder of the fault's potential. The stress built over 150 years must eventually be released. The Hayward Fault's high slip deficit is a looming threat. The 1906 San Francisco earthquake, a magnitude 7.9 event, offers a cautionary tale. A moderate quake the night before was a foreshock, a warning of the devastation to come. This historical example shows that small quakes on major faults can precede larger ones. The 1906 foreshock is a reminder that we must treat every noticeable quake as a potential warning. The Hayward Fault's history suggests similar patterns. The 1868 quake may have been preceded by foreshocks. Living in the Bay Area means living with these legacies. They are blueprints for the future, urging better monitoring and preparedness. While we can't predict quakes, the ShakeAlert system offers crucial seconds of warning. It uses seismometers to detect initial P waves and sends alerts before damaging S waves arrive. Alerts can reach your smartphone, giving time to drop, cover, and hold on. ShakeAlert can save lives, but it has limitations. Those near the epicenter might not receive a warning in time. Personal preparedness is essential. Don't rely solely on technology. Secure heavy furniture, create an emergency kit, and have a family plan. The motto, don't be scared, be prepared. Earthquakes are a natural part of California life. The Berkeley quake was a drill. Now is the time to prepare for the real thing.